Hi everyone, thanks for coming to my talk. I'm going to talk about hypermedia actors in F#, or an alternative title would be agent versus agent, and I'm going to look at what that means in a little while. My name is Einar Høst. I'm a Norwegian software developer. I've been writing code professionally, I guess, for 20 years now. I work for Norwegian Labour and Welfare Administration, and this is sort of a disclaimer. This is primarily an idea talk. There's F# in the title. How many here has written some F# before? Okay, so how many have not? So roughly half and half. Okay, cool. There will be some traces of F# in the talk, but sort of that's basically more or less an implementation detail. So I'm primarily going to talk about three ideas, and it's going to be sort of also a strange mix of a talk, in that it's going to be a serious talk and a whimsical talk all at once, because I think that's the best kind of talk for me. The serious part is going to be about the ideas, and then I'm going to apply the ideas to a silly example, right? So the ideas that I want to talk about are three ideas. There are two of them in this title, Hypermedia and Actors. So there are three old ideas. And I guess old ideas that we still remember are the best ones, because the bad old ideas are all forgotten. When I say old, I mean ideas that are older than myself. And looking at the audience, it probably means older than you as well, right? Most of you, at least. So the first idea I want to talk about is actors. The idea of actors is barely older than me, 2 years older than I am. It was formulated by Carl Hewitt in 1973. So 2 years before I was born. And the actor model is a mathematical model that treats actors as the basic unit of computation. Well, okay, what does that mean? It means that if you have some computation going on in your program, that computation is going to be the work of an actor. An actor is a pretty simple thing. There are three things that an actor might do. When it receives a message, it might send some messages to other actors. It could create some new actors, and it might determine what it's going to do next time. That's going to be a state change inside the actor of some sort. That's the first idea I want to talk about. The second idea is finite state machines. That's an even older idea. So this is like the grandparent old, or maybe even great-grandparent old. So it was sort of theory of state machines was formulated in the 1950s by Moore and Mealy. We're not going to go sort of in the technical details of what a Moore machine is and a Mealy machine is. We're just going to sort of take a high-level view of it, I guess. So a finite state machine is another of these mathematical models, and it's a mathematical model of computation which is based on states and transitions. So what does a finite state machine consist of? Well, it has a finite set of possible states, and it has a notion of what the current state is. And it has some conditions for transitioning between the different states. And that can be nice when you're trying to create computer programs, because you can sort of distinguish between different things. In particular, what separates the state that you're programming from the conditions that is necessary to enter some sort of a different kind of state. So it allows for sort of clean separation of things, which is nice in computer programs. And if this works, this is the third idea I want to talk about, is hypermedia. And this, for me, is interesting because, well, I think for one thing, it's simultaneously the oldest and the newest of the ideas. And I think it's also, paradoxically, the most widespread and probably least understood of the three, which makes it a very interesting idea. Now, when we think about hypermedia today, we sort of think about Tim Berners-Lee style hypermedia, which came into being in 1989, which is decidedly younger than I am. And that's sort of the hypermedia that underlies the web as we know it. This is the first web browser created by Tim Berners-Lee at CERN. But the idea can be traced further back. I want to mention Douglas Engelbart's work in the 60s. This here is a picture of Douglas Engelbart himself doing the famous mother of all demos in 1968, where he demonstrated a system called Online System, or NLS. That's a system very advanced for its day, which had sort of simultaneous editing of documents and links between documents and so on and so forth. So it had some of these hypermedia capabilities. Douglas Engelbart himself today is mostly famous as sort of the father of the computer mouse, and he demonstrated that as well in the same demo. But it's sort of his main work was in using system to augment the human intellect. That was sort of his game or his goal. And you can't talk about, well, you can, and you often do, but we shouldn't talk about hypermedia without mentioning Ted Nelson, who was sort of the main visionary for hypermedia, I guess, and one that coined the term hypertext sometime in the 1960s. And for him, the big thing was these connections, the links between things, and as he said, everything is deeply intertwined. He was fond of coming up with these new words, as you can tell. And this is a mock-up of Ted Nelson's vision for hypermedia. It's called Xanadu. Unfortunately, it never became a reality. But the idea itself can be traced even further back to a paper by Vannevar Bush from 1945 called As We May Think. And that was sort of influenced, I guess, by the available technology. So the idea was, in the paper he describes a system called a Memex, which is basically a mechanical desk where you can push different buttons to navigate between different documents that are small rolls of microfilm. And then you have sort of a magnifying glass and all the world's information sort of contained within this desk, which is both very similar, I guess, to the ambition of the web, and yet so very different. But okay, so the hypermedia thing that we're going to talk about today is dub style hypermedia. And a hypermedia document then is a media document that has some meaningful links to other documents, other such hypermedia documents. And what I say by meaningful link, well, when you talk about links, we often think just about a URL, sort of the address where I can go to fetch the next document, right? But a meaningful link sort of means that the link also describes the relationship between the two documents and what it means to traverse that link, to sort of navigate from wherever I am now to this next place, right? And it's easy to forget that, but that's why we have things like the rel attribute in HTML and so on and so forth to describe the semantics of the link. Okay, so those were the big ideas. These are sort of the serious part of this talk. These are big and abstract ideas, so I thought I'd try to make it a lot more concrete. So I'm going to try to mix all of these ideas into a single project. And this is my project. This is Spy versus Spy, which is another thing from the 60s. It's a cartoon that's been running for a long time. It originated in Mag magazine in the 1960s sometime. And it's kind of a parody of the Cold War, right? So we have these two spies that are constantly trying to trick each other, blow each other up, and steal secret documents, and so on and so forth. That's the gist of it. So the plan then is that I'm going to try to show you how I mix these ideas to create a game, which is a hypermedia-based multiplier spy versus spy game based on actors in finite state machines. Okay, so we've been through the ideas, and I want to repeat the sort of that there is something serious in this talk, right? So I want to talk a little bit about the real-world problems that you can use these ideas to tackle, and then we're going to look at the actual game itself. That's going to be called Agent versus Agent. I'm going to look at the conceptual design, how I try to apply the ideas. Take a little bit of a look at the implementation. That's going to be the part where we see some F#, and if we have time, we might play the game a little bit, which is going to be interesting. Okay, so the problems that I want to talk about. Say you have a web API, for instance. A lot of us write web APIs these days. And you have a bunch of different clients. Those could be desktop clients, mobile clients, your smartwatch, your iPad, anything that's capable of talking to your API over HTTP. And the challenge that we're faced with, okay, in an architecture like this, how can we build an application that can evolve over time? Because we want You want things to evolve. You want things to evolve rapidly, ideally. And how then can we do this evolving without breaking clients? Right? The client is working today with whatever functionality we have implemented, but we want to evolve the application. How do we do that? And how do we do it in such a way that we don't have to synchronize the update of all these different things, right? Because these could be clients that are owned by different people. You might not be able to control their schedule of updates, and so how can I update this without breaking everything else or putting everything on hold? So how do we do that? Well, the fundamental problem for a client-server architecture is that you have to agree on the semantics somehow, right? So you're doing some sort of information exchange from the server to the client. How do we agree on what those data mean, right? What is the contract between the client and the server? And also, is that contract made implicit or explicit? So we have it documented somewhere, written down what it means, or is it just, well, whatever seemed to work in the past should still be working? So there are two fundamental questions, I guess, you can ask. Well, the first one is, what can the client trust to sort of always be there? That's sometimes referred to as backwards compatibility, right? So whatever change the server might make, what can the client still rely on being there? And conversely, what is the server able to change freely? Those are mostly going to be additions, right? So you can add things, perhaps, that the client doesn't rely on. Removing things might be difficult because those might be things that the client rely on. This is sometimes referred to as forward compatibility. So the client should be written in such a way that seeing things that it doesn't understand is not a problem. Just ignore it, and then sort of work with the things that you do understand. Now, often these APIs that we make have sort of used JSON as the format of data exchange. JSON is a very weak contract. So the only thing that a JSON document says is that this is going to be a nested set of key value things, right? That's sort of the guarantee that JSON provides for you. Okay, so that was the first challenge. Second challenge is, well, if we have created a sound set of abstractions that sort of describe our problem, how can we build those in code in a way that's robust? And we want then some properties like, let's see if this works, independence. You want our clear boundaries for our abstractions. You want some sort of encapsulation and isolation from the influence from other things. And we want our abstractions to sort of be able to run in concurrent and parallel. You might be able to see where I'm going with this. This is sort of a good fit for the actor models. I'm basically describing the properties that the actor model gives you, right? And similarly, how do we reason about the code? Well, the important thing, when I say reason about the code, it's just as much reasoning about the behavior of the application, right? And a fundamental thing is going to be, at any given point in the running of the application, what state is the application in? That's typically a difficult question to answer because, well, the number of possible values in your program is probably almost infinite, right? So we've been, I think, traditionally at least, very bad at answering fundamental questions like this. And there's a growing awareness for the need of sort of observability in applications, but I think we can still improve a lot. I should be able to answer sort of fundamental questions, well, what's going to happen next in my program? So if I am in some state and I get some input, what's going to happen? Well, presumably, the result of processing that input is going to be that I'm in, well, another state. It could be the same state, depending on whatever the input was. Or it might have changed, and it might have produced some output. And I want to have some feeling of control over this process, and that's where the finite state machines come in. This is, sort of, again, playing to the strengths of the finite state machine model. Okay, so those are the challenges. Let's look at how they apply to this game that I wanted to show you. Okay, so in designing my game, I took inspiration from an existing game. This came in 1984, and it was one of my favorite games on the Commodore 64. I played it a lot at the time. I probably got it a year later or something like that. It was something like 10 years old. And this is a splash screen for that game that I played. And this is a sort of a screenshot for what it looked like. So you can see the screen is split in two. On top, you can see you follow the actions of the white agent. And on the bottom half, you follow the actions of the black agent. And those two both have the same goal. So they're trying to pick up some, I think there are 4 items they're supposed to pick, to put into a secret folder, and then to make a getaway and escape before the time runs out. You can see there's a counter here that counts down, and when it reaches 0, I think it blows up or something like that. And they can place various kinds of traps for each other, right? So there's a bomb, there's a strange thing with a string and a gun. To get a feel for it, I'm going to see if we can actually see some gameplay. So you can see that they're sort of running around looking for things. White agent found a folder. They're messing about. Black agent found something. Now here, the white agent is closing the door and is placing a trap now. This is one of those gun things. And here the black agent encounters that door and is shot by the trap. And well, he will recycle or sort of regenerate at some point, but he sort of loses some time and so on and so forth. That's the gist of it. So let's move on. Let's see. Oh, okay. So on to the conceptual design of the game. So I took inspiration from this game. It's not going to be sort of fully featured. Unfortunately, also it's not going to have any graphics. So it's going to be entirely text-based. But it's going to have the same fundamental idea. So this is what I drew up for my game. So I created some rooms. These are basically just the first names for rooms that popped into my head when I got this idea. There is no deep meaning between them, but you can navigate between these different rooms, right? So you can go from the office to the control room to the laboratory and back if you like. Most of the paths are going to go both ways, but there's a sort of one-directional thing from the teleport to the exit, because there's the idea is that there's some sort of teleportation device that teleports you directly to the exit, and you can see there's a dotted line for the plane that takes you away from the game world. That's because you need to have the secret file in order to actually escape. Okay, so this is what a sketch of what the gameplay might look like. This is the black agent now in the office. When the game starts, he's dropped in some room at random, right? And the secret file is also dropped somewhere at random, and the black agent might navigate around like this, goes to the control room, goes to the exit, realizes that I can't really escape here because I don't have the secret file yet. I haven't accomplished my mission, so I need to find that first and bring it with him. So he goes looking some more, observes that the secret file is in the laboratory, goes to the teleportation room, goes to the exit, and catches the plane away, and he's, yay, won the game. But that's much too easy. Even I don't think that's a very amusing game. So we need to add adversaries, right? Other agents, at least one other agent. Like the white agent is a fairly obvious one. But we can very easily generalize that. We're not restricted. The good thing about not having any graphics is that we're not restricted by screen real estate. So we can have as many agents as we want. We can have a gray agent, a pink agent, a blue agent, a green agent, so on and so forth. So at least one dimension where my game is better than the 1984 original, right? Where it's more like web scale with respect to the number of agents. And we need a strategic element, something to shake things up a little bit. So I've added bombs. I don't have all the kinds of traps, but bombs I think are sort of fundamental to the spy universe. We needed bombs. So this now is a much more realistic still image of the state of gameplay at some point. There are two agents, the black and the white. The secret file is there, and there are two links now with bombs on them. And the idea is that you can put a bomb on a link between rooms, and if an agent comes along and tries to traverse that link now, it's going to trigger the bomb, and it has to disarm the bomb or explode. And if he has the secret file on him as he explodes, he's going to drop it. Okay. So let's try to apply these ideas in this talk to this game. So those are the ideas of actors. state machines and hypermedia. So first, actors. So I've implemented my sort of game server in F# using ASP.NET Core and Giraffe. Again, that's sort of an implementation detail, so I could have chosen some other actor framework for the .NET framework, such as Orleans or Akka or something like that. I could have chosen something like Elixir or Erlang that's famous for the implementation of the actor model, but I chose F# agent because it sort of comes out of the box with the F# language, and F# is sort of my go-to language for my, well, for a project like this, I guess. So the idea is then to make everything that I've talked about in the conceptual design into one of these agents. So the rooms themselves are going to be agents. That means that if you want to do something to a room, you're going to send a message to it. That's what you do with an actor, right? You send messages to them. So it could be a message to plant a bomb on the entrance to the room, for instance. The secret file is going to be an agent. You might send a pick me up message to the secret file. Or you could send a drop message to it. The getaway plane is going to be an agent. The bombs will be agents. And of course, finally, the agents themselves are going to be agents also. Okay. So, to reiterate, what can you do with an actor? When an actor receives a message, it can send messages to other actors, it can create new actors, and it can determine what it's going to do next time. So some examples of that from the game. When the client sends a pickup message to the secret file, well, then the secret file agent is going to change state to taken and send a message to the agent to let the agent know that they now have the file. When a client sends a plant bomb message to some room resource, then a new bomb agent is going to be created. So we're creating a new agent now. And the room will change state to booby-trapped. When a bomb explodes, it's going to send an exploding bomb message to the agent and a drop message to the secret file. Of course, that's going to be bad news for the agent, I guess. It has to respond to that somehow. And to model how the different agents respond to things like that, that's where the finite state machines come in. So each model is going to be modeled as a finite state machine. This is the agent. When the game starts, the agent, or the initial state for the agent, I should say, is going to be alive. And then there are two things that a live agent might do. It could pick up the secret file, or it could explode. If it picks up the secret file, it's going to be now in an alive with file state. And then from both those states, there are transitions for the explosion event. So if in either of those states, if you receive an explode message, you're going to end up dead. And then immediately, when you're dead, you're also going to transition right back through a resurrection message, or a resurrection transition, rather, into the alive state. But that means that you're no longer alive with the file, so because you dropped the file, right? That happens when you die. So for the bomb, it starts out in the armed state. If an agent enters the room through the link that is booby-trapped, it's going to be triggered. And then this is, I'm sorry to say, this is hard-coded. You should always cut the red wire to disarm the bomb. So it's not, I'm going to accept pull requests to make this sort of a choice for the agent planting the bomb, which is the only thing that makes sense, right? But for now, as long as you cut the red wire, you're safe. If you cut the blue wire, you explode. Or the bomb explodes, rather, and that, as a consequence of that, you explode. Secret file can be in one of two states. It's either going to be available in some room, it can be picked up then, which is going to make it taken, and then it can be dropped, and so on and so forth. So those are the finite state machines things. So finally, the idea of hypermedia. So fundamentally, the game is going to be a client-server architecture. This server is going to be written in F# with Giraffe. The client is going to make HTTP requests and get HTTP responses back. in a format called Siren. We're going to talk more about Siren later on. The client actually going to be it's going to be a client I wrote. Actually wrote for an earlier game. It's called. It's written in Node. So this is an example of software reuse, I guess. Right? Now the idea from a Hypermedia stance is I'm going to expose each entity as a resource. So I said earlier that everything is going to be an agent, but everything is really going to be a resource, which means it's going to be sort of a tuple of a URL and an agent, which makes the agent addressable for the client. And as I mentioned, I'm going to use something called Siren as the Hypermedia format. That's going to be the format of the responses that I send back. Siren is a format created by Kevin Schreiber. You can read more about it here. This is the MIME type for Siren. So it's every Siren document is a valid JSON document, but it has some additional guarantees, right? So it has some specification on top of just being valid JSON. It needs to fulfill some more criteria, which allows for a richer client-server contract. It means, we talked about earlier, what can the client trust to be there? The client can trust some properties of the Siren document to be there, and those properties are going to be enough to drive this application. And this is actually also the reason why I could reuse my client from an earlier game, because it's the same contract, right? So every Siren document is going to have a property called links, where you can put links. And those links are all going to have a certain structure. I'm going to use those links to navigate between different rooms in the game. And then Siren also supports something called actions. Those are for hypermedia controls. The best way to think about that is like HTML forms. Right? It allows the server to specify to the client, OK, I'm going to need data that looks like this. So can you send me data on this format? That's what HTML forms does, and that's also what actions in Siren do. I'm going to use those actions to drive the state transitions in my game. Those are going to be through post, put, and delete on a resource. So the links typically going to be HTTP gets. The actions mostly going to be post, I think, in this case. I'm going to use that to plant a bomb, to disarm a bomb, pick up the secret file, and so on and so forth. This is, if you can see it, this is an example of an action as specified in a Siren response. The name of the action is plant bomb. HTTP method that we're supposed to use is post. The link, in this case, is going to be some room. And then there are some fields that I need to fill out. In particular, I need to fill out the bomb referrer, which is basically where the agent is coming from when entering this room. It says, which entrance are you placing the bomb on? OK, so this is my bomb. State machine for the bomb. Initially in the armed state, you can sort of look at it in that state. But if you go into a room where the reference header matches the link that's sort of specified in the bomb reference, then it's going to be redirected to look at this bomb. And at the same time, it's going to enter the triggered state. And the only thing you can do in the triggered state, you're going to have no links for further navigation. And the only thing you can do is do one of these Siren actions, is to try to disarm the bomb. And then again, if you cut the right one, everything is going to be OK. If you cut the blue one, you're going to be redirected into a random room, and you will at the same time enter the dead state, be resurrected, and lose the secret file if you had it. And that's sort of the end. Then the bomb enters the end state, which is gone. And if you try to access that resource in some way, you're going to get sort of a 410 response that says this resource is no longer here. An important thing is that these links and actions are dynamic. They depend on the state of the game. So we use these. They're not static. So you use these to actively guide the player to what's possible to do now. So for instance, that means that there is not going to be a link to the getaway plane from the exit room unless you're in the state where you have the secret file. There is just not going to be any link there, so you can't go there. And then the final thing you can trust to be there in a Siren document is a property called properties. That's basically just for a JSON blob or whatever. So anything could be in there. I use that for telling a story. So an example for that, I'm just going to show that into my client as a dump of information. So this is the black agent, the description of the black agent. You are the brilliant and sly black agent. You are currently here in the laboratory. You have the secret file because you're a clever genius. This is the black agent as seen by the black agent, because that matters. So this is the black agent looking at the white agent, which says, it is the cowardly and deceitful white agent up to no good as usual. So perspective matters. Okay, so the implementation now, let's see. Yeah, we're fairly good on time, so that's good. If you're interested, you can sort of poke around. It's not the world's most beautiful F# code at all, so be gentle. It's very pragmatic, weekend-style coding, if you like. But let's see. See if we can take a look at a little bit of the code. Is this, can you read this, or is it perhaps a little bit small? I think I'm going to try to up the font size a bit. Oh. Everything is super slow. I haven't opened a folder. Are you kidding me? Oh. Oh. That's the wrong one. Sorry about this. So it's going to be over here. I have too many folders. Is it still? Wow. Oh, you're actually seeing some code. I'm very confused now. I'm sorry about that. It's because I think I have two instances open. Let's just look at this. Okay, so this is my routing. So there are a bunch of different endpoints. You start out the game by hitting this endpoint, start. And that's going to be handled by something called a start handler. And then there are sort of handlers for each of the individual rooms. And there are handlers for the agent and the bombs and the secret plane and the getaway, secret file and the getaway plane and so on and so forth. Just going to look at a few of those. So let's see. This is the start resource, which is what you're going to hit when you start the game. Let's see. What can you do with that? Well, this is a start agent. So it's going to receive a message. And then there are two things you can do. You can send it an HTTP GET, in which case you're going to call this function. And that function is basically just going to say, OK, what can you do now? Which is basically presenting you with one of these actions to start an agent. And if you perform that action, you're going to make a post request, and that's going to allow you to create one of these agent resources, and so on and so forth. Right, that's the start resource. Then we might, I just want to look around a little bit. The start resource is not very complicated, so it just has one state. The secret file is a little bit more interesting. So this is the agent for the secret file. It's going to start out in the available state. So the way that this works in the code is that when you have multiple states for an agent, that's going to be implemented by a sort of a mutually recursive function. So each, this is one of the states is available. And then further on down here, there's a different state called taken, which is the other state that's possible for the secret file. That's going to be taken by some agent. And depending on those things, well, if the secret file is available, then it's, well, we should look at the possible messages that we can send to the secret file. So the things that you can ask a secret file about is, first, what is the location of the secret file? Then you can send it a dropped message, and then you can send it a web message, which basically says that this comes from the player, from the client. So the two top ones are sort of internal for the game. The last one is something that the client is going to send. Now, if the secret file is available, well, then it's basically just going to, and it gets one of these location queries, just going to reply with the room location. If you send it a dropped your message while it's available, that doesn't really make sense, so I'm just going to print an error message, because you can't drop a file that's already lying somewhere in the room. It doesn't make sense. But if you send it a web message, you can either look at it through a GET or pick it up by a POST. And if you pick it up, that means you're going to try to notify the agent that it picked up the secret file, and so on and so forth. Yes. Whereas if it is in the taken state, then it will respond meaningfully to the dropped event, which is going to return it to the available state. At the same time, you can't really interact with it as a client, because that doesn't make any sense, because it's not available now, so it's going to just say 404 if you try to access a resource that's already been taken. Okay, so at this point, maybe it would be clearer if we try to play it a little bit. We'll see how that goes. So I'm going to start up the game now. Okay. That's going to be, let's see. Wow. Okay, so I have, this is, well, I'm going to need 2 of these, right? So I have my server running, and I'm going to have 2 players. So I need a terminal for each player. I'm going to start my client. And, well, actually what I'm doing is I'm navigating to this URL, which is where my game lives. And what happens when I do that is that I make a HTTP request with a GET. I ask for some siren. I get a 200 OK back, which says that, yes, you got some siren. And that looks like this. Now, the nice thing about this being siren is that I can trust these actions and these links and these properties to be there, right? So I have some guarantees, and this makes it possible for me in my client to build some functionality on top of that. So I can, for instance, list out the different links that are available to me. In this case, not a whole lot of links. I'm not sure if you can read this. It says it's just a self-link back to the same resource. I'm always including a self-link. This is to enable things like basically pushing F5 in your browser to refresh. You should always have a self-link to do that. But more interestingly, there are these actions. And I have my action here now to post a start agent operation. And I have some sort of built-in support for that as well, because again, this is how Siren works. So I can I've created a do command, which is going to look up the name of I can sort of identify an action by name, in this case, start agent. Let's see, agent. This is going to be the black agent. It's actually impossible to type correctly on stage. What happens then is that I post my request to start an agent, and I get a 302 found, which basically is going to place me somewhere in the game world. This found comes with an HTTP header, which I can follow. So again, things that I can trust in my client are basically going to be 2 things. There's going to be the things that are guaranteed by Siren and the things that are going to be guaranteed by HTTP itself, the protocol itself. So if you get a 302, you're always supposed to get a location header, and I can create things in my client that rely on those things. And let's see, I can look around now. And I have my description. It says, you're in the secret research laboratory, gadgets are whizzing. Oh, you found the secret file. I was super lucky in this case that the agent and the secret file was dropped in the same place. But of course, I could try to catch up. Well, I'm going to cheat a little bit. I have built in, and I don't have to type out the URL for the start point. So I just call the hyper agents to start my game, and then I can say, okay, I'm going to start off my agent. This is the white agent. It doesn't really matter what colors I choose. Let's see if I can type correctly. I'm in this exit room. Do I have the secret file? Then you should get out of here. Well, I don't have the secret file. That's the problem. And I can see that because there is no link here. So I just list all the links. There is no link here that takes me to the exit or the getaway plane because I don't have the secret file. The one that has the secret file is, or could have the secret file, is this black agent. And I think, unfortunately, we're not going to have time to demonstrate the bombs, but you might be able to pick up the secret file. So the links here are sort of, I can access them numerically, so basically just an array from 0, 1, 2, 3, 4, 5 is going to be the secret file. So I can go to that link, look at it, and says, this is it, the secret file, grab it, get to the airplane, don't get blown up on the way. So I can do take file, which now gives me the secret file. And I can take a look at myself. And this is the description we saw before. Brilliant and sly black agent, you are currently here in the laboratory. You have the secret file because you're a clever genius. Excellent. Let's see, where can I go? Well, in this place, I'm just looking at myself now. So the only thing I can do is go back to the room where I am. I'm in the laboratory. I should be going to the exit now. Right? So do I have the exit here? Not yet. I think I'm going to have to go to something like the control room first. Probably. 0, 1, 2, 3. See if that has an option to go to the exit. 0, 1, 2, 3, 4. Okay, I could go to the exit now. Let's actually, let's create some problems. Okay, so this white agent now has the option to plant a bomb on the entrance from the control room to the exit room. Let's try that. Plant bomb 0. And I get a 201 created, which says that something was created on the server. That's going to be the bomb resource. And now let's see what happens when I try to go to the exit. And that's going to be 0, 1, 2, 3, 4. And the bad thing is, I was supposed to go to the exit room, but because there was a bomb on the link, I get a 302 redirect to this other place, which is the bomb. And in that situation, I don't have any links, so I can't go anywhere. The only thing I can do, the only thing I can do is follow along. And also here, when I follow along and look at the thing that I'm encountering, is that I have a Die Hard-style scary bomb, and the bomb is ticking, and there are, again, no links, only actions to cut the wire. Now, which one was it? Was it the red or the blue one? I actually forgot. I'm just going to try something. Oh, I think I did the right one. Yes, excellent. Otherwise, I would have been redirected, which means the same as exploding. Which is kind of strange. It's very unsatisfying in the game. The only thing that does is that you're redirected somewhere else. So there's a room for improvement in the game there. Let's see. I have successfully disarmed the bomb. That's excellent. And now I have actually links because I disarmed the bomb. I had no links before because there was a bomb there. Now it is disarmed and I can go on to where I wanted to go, which is the exit room. And I'm in the exit room. If I have the secret file, I should get out here. It also notes that the black agent is there. But that doesn't really matter, because I now have, I don't have. I think I probably messed something up. Let's see. I should have had the plane here, but apparently I probably have a bug. Well, thanks. I think we're going to end there.